WinForms.
A little bit of WinForms.
WinForms. MFC. Any MFCers?
What a shame.
Okay.
Cool. Well, should we get started, Paul?
Yeah. So I'm Paul Gusmorino, by the way. Thanks for everyone here and watching on the stream as well.
My name is James Clarke, a peer of Paul's at Microsoft.
So what are we going to cover, James, today?
Well, we wanted to try and demystify a little bit some of the different native UI platform technologies that Microsoft offers. So one quick disclaimer, if anyone here is expecting to see any web or kind of hybrid development, there are other great sessions covering that. We will not be covering that. We will unashamedly be covering native UI. So we wanted to demystify some of these and give you something of a roadmap to show you how we're planning to move the platform forwards.
And so we're going to kind of give a bit of a big picture of how we're evolving the Windows 10 platform, and then we're going to deep dive into WinUI and the future of native UX development, and then wrap up with some kind of pointers to how to get started with stuff. And so going into the big picture, we're evolving the platform to help you make the most of the Windows 10 developer opportunity. There are now nearly 1 billion devices running Windows 10, and these aren't just old PCs upgrading. This includes an increasingly diverse, modern set of form factors. Hundreds of millions of devices now have touchscreens. There's ARM-based, always connected Windows 10 computers. And there's next-generation dual-screen foldable devices that we just announced a month ago at the Surface event. And finally, Windows 7 is reaching end of support in a few months. And while this represents a challenge for many people to complete their upgrades to Windows 10, it also represents an opportunity for developers to shed some old requirements and consider what's next. And Windows 10 is letting people work in familiar ways and in whole new ways. Powerful multi-mon desktop workstations, ultra-portable laptops and convertibles, digital whiteboards, IoT small screen devices. And people are changing the way they interact with computers and the way what they expect of software and how they expect it to be always available to them across all these devices. And so we see these as opportunities for you as Windows developers that we're evolving the platform to help you realize. And we want to help you make apps that look and feel and work great and really are successful for you and your customers across the ways people are working today and the ways they're using their devices today. And it's fun that we have a bunch of the whole Surface lineup of devices here, but there's also the whole ecosystem of Windows 10 devices beyond that. And so how are we evolving the platform to help make this happen, James?
Great question, Paul. So really, in a number of ways. So as we mentioned, obviously we have a significant number of new form factors with new input modalities. And so at a platform level, we've really had to spend quite a few years now making deep investments in the stack to really make sure that things like ink and touch are plumbed all the way through Windows. And it doesn't really just stop with kind of those levels of natural user interaction, but also if you think about scenarios, augmented reality, and our HoloLens device, and our big screen devices, we've had to do optimizations to support all of these. Now, when we think about user experience, users have very clear expectations that have been set by the prevalence of fluid, modern user experiences throughout the world that they live in these days. And so building a new UI platform that makes it effortless for developers to build these fluid experiences, things like Fluent Design, and also things like making it easy to customize your experiences and tailor them to your brand are really important. We've had to do deep work there. On the app deployment front, historically, we had kind of problems with app deployment. We had your machine would get worse over time. You'd have to reformat it. So we really wanted to try and solve that by doing not only new mechanisms of packaging and installation and management, app stores, and new ways that allow you to distribute apps into your enterprise. So things like private store for business, that kind of thing. On the reliability, security, and privacy area, I'm sure many of us here have seen that sign. In fact, there may be people here today right now amongst you who have taped over their webcam because we really don't trust that computers and technology will do the right thing. And so this is, again, a place where we've really had to raise the bar in Windows and do deep engineering work, change the way that certain APIs work to really put the user back in control of their privacy. And then finally, when we think about stuff like system performance and battery life, as the devices shrink and as they add more screens, we just announced, as Paul mentioned, dual screen devices, there's more and more pressure on that precious battery life. And so again, in Windows, we really need to do and invest in engineering the system such that battery life is deterministic and manageable. So, Paul, how are we going to meet the needs in the platform?
Yeah, so what we did to meet all those needs that James talked about and try to create this opportunity for you is provide a modern generation of platform technologies in Windows 10 known as the Universal Windows Platform. And it's enabling developers to build awesome cutting-edge experiences for Windows 10. Experiences that are used by hundreds of millions of customers every month and that are accruing billions of hours of usage on the Universal Windows Platform. And so that's fantastic, but at the same time, we know not all developers have been able to take advantage of these new technologies due to how they're being delivered. And so we're transforming how we deliver our Windows 10 technologies to you to be more agile and interoperable and open. If you think about the way the world has been, there's sort of the Win32 desktop stack of technologies, and there's the Universal Windows WinRT platform stack. And they've been sort of these distinct entities. And there's been this idea that you're either creating a desktop Win32 app or you're creating a universal WinRT app. And that's created sort of this big left-right decision in people's minds about, oh, do I go this way or that way on it? And it's created gaps for people because of availability on deployed OSs. So if your organization still has Windows 7 computers, that's held you back from being able to use the Universal WinRT platform because it's not available there. Or even if they don't have the latest version of Windows 10, you haven't been able to use the latest features of the platform that many of you want. There's tension because of interoperability with existing code and existing libraries people are using, often libraries that are closed source and they just have a binary drop of it and they don't even have flexibility to go modernize it. And there's been specific features missing in both stacks. And these have all kind of created kind of a gap and some tension for people in how we've delivered the platform to you. And so we're filling that gap by enabling you to pick the right blend for your app. That's really how we're trying to move forward as we think about evolving the platform. And so we're lifting components out of the system OS, out of the Universal Windows Platform in the OS to be delivered independently of the operating system, things like MSIX and WinUI that we'll talk about. We're making components more interoperable across the desktop and UWP technologies so they're easier for you to use and mix and match. And we're open sourcing a lot of our components because that'll create more agility for us to work with you to fix any missing feature gaps or bugs or whatever it is that you need to unblock you and make you successful with the platform. Now, to be clear, it's still meaningful and valuable to create an app entirely on the Universal WinRT stack. That's the only way to create a fully native app to reach all Windows, all the devices and Xbox and HoloLens and other devices in the future. But we're trying to be more inclusive in general in how we deliver the platform to let you have the right blend for you. To help you understand what we mean by that, I think we're going to dig in now a little bit into the layers of the platform and how we think about that and what we're doing in each layer. And so we kind of broadly think about there being a UI layer, an API layer, and an app model layer. And so let's dig into it and talk about the UI layer first. When Windows 10 first came out, I guess 4 years ago, if you're a desktop developer, the UI technologies you had were User32 and COM control and WPF, basically. And if you're using WinForms or MFC, those are actually built on top of User32 COM control. So that's the core technology you're actually using from a UI layer perspective. And if you were doing a UWP development, you had the new modern Windows XAML and the visual layer, composition, and all the effects and richness that had. What we've gotten to already now is we've extended the visual layer so that a lot of it can be used directly from Win32 desktop apps, and James is going to do an awesome demo of that. We've added XAML islands that allow you to use Windows XAML framework from desktop apps. And we've also introduced something called WinUI, which is a new library that ships independently of the operating system and is the vehicle through which we ship new controls and styles and features now. And where we're going is we're continuing to grow WinUI, and we're going to take all the key pieces of the UI layer and put them into WinUI to give you that better delivery mechanism that's more agile and more interoperable and more open for you. We're going to talk about that more later, but first we're going to start with a demo of what you can do already today with the visual layer in desktop apps.
Let's do a demo. So what I want to show you next is how we, click next on the slide, how we've worked between the Windows team and the Office team to use the power of the visual layer to enhance some of our Office productivity apps. So we'll switch over now to the demo machine. I'm sure everybody in the room pretty much is familiar with Word, and I'm also fairly convinced that when most of us first used Word, the first thing that we would have learned how to do is to kind of simple things like scroll through the document using the mouse and using scroll bars. And that's absolutely kind of how things started off back in the beginning. But with the advent of touch and with touch devices, all these great Surface machines, you just expect to be able to touch the screen and do direct manipulation. And so we've worked with Office to leverage a couple of technologies from the visual layer and also from the input stack to bring some of that power to Microsoft Word. So if I come in and just start panning, as I would expect, I get a natural fluid panning experience. I'm just touching the screen. And if I need to zoom in and get more detail, I can get pinch zoom here. And notice the incredible performance. And the reason that this is so fast is because we're using the visual layer, all of the optimizations in Windows itself, to power this zooming operation. Now, one of the great things that Office found, particularly in the Word app when they adopted it, was their memory usage went way down because suddenly they're actually leveraging the system to do something previously they had to do in their own code. Now, what's another common interaction? Well, I've got a pen here, and one of the things that is interesting about the pen is that you can think of it in terms of how I might want to annotate a document. But also, Office have been able to leverage the pen for things like selecting words. And so they have this magic ink editor, which I have to enable. And then when I circle a word, it will actually treat that operation as an editing operation on the document, which is pretty cool. But if I come in and do my regular inking, this is powered by a technology called Direct Ink. And Direct Ink, again, is an API we built originally as part of the UWP or Universal Windows Platform, but is now available to Win32 apps. So I can come in here and do my annotations, if I turn off there, and get really performant ink responsiveness, and that's because we've done this deep work in the platform to really optimize. Now, you may look at this and go, well, how do I know this is actually using the visual layer? Well, if we come in here, we actually have a little diagnostic tool here that we can come in, I can come and select my ink stroke, and this actually shows the visual tree that Office is building under the covers. It's an internal tool that we use for diagnostics. And if I come down to my ink input panel here and actually say go to visual, what I now see is the visual tree that is being built using the composition API, the Windows compositor. And I can actually see this fairly deep visual tree. I can also see that Office are using the Sprite Visual API, which is one of our APIs for the visual layer. So that's a great example, hopefully, of a first-party Microsoft app leveraging the visual layer and leveraging WinUI. Paul, what about third parties?
Yeah, that's awesome. Office using UWP there. And so it's not just Microsoft apps, but Microsoft's working with the broader industry in adopting these technologies. And for XAML Islands, I'm going to show a demo with Siemens FEMAP. This is an advanced engineering simulation application for working with mesh-centric finite element analysis and doing lots of important engineering work. And it's a powerful desktop app that's built with MFC and C++. And Siemens wants to evolve this app to be able to leverage the latest hardware, including high DPI screens, as well as those new input types that James showed, the latest in software capabilities in graphics and media and 3D. And they just want to be able to write to a more modern UX API with easier customization than what they've been able to do in the past. And so I'd like to show you a proof of concept that Microsoft and Siemens have been working on of how the FEMAP app might take advantage of this. So here I have an app that I think you can instantly see, just kind of looking at it, is a Win32 MFC app. You see panes and toolbars and status bars and things. One of the first things that people wanted to do here was replace the old tree view with a modern XAML tree view control from WinUI because that works great with high DPI by default. It has all the customization capabilities they want. And so this is actually using a XAML island in this Win32 app to use XAML and get the modern XAML tree view control here. Another thing they want to do is be able to take advantage of things like inking. And unlike Office, which wanted to write to the very complicated, not very complicated, but the very powerful and rich visual layer, in this case, people just want to be able to use simple controls like the ink canvas control and scroll view control to get these capabilities. And so just using an ink canvas control, they can immediately start having like inking annotation support very easily. They can access using scroll view controls. So here I have scrolling and zooming with all the right scroll bar behaviors and so forth, just using a scroll view control right in this app. And also things like modern text box control. So I can say, hello, Ignite developers. And because it's a modern text box control, it has all the rich features of modern text boxes. So it has spell checking and proofing kind of tools built into it. It has touch selection model, so I can double tap on words to select them and instantly get that little floaty with, pop-ups, and I can say developers, 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 because we love developers. You also can access the rich media playback controls. And so this is something that has not just a new UI, but support for closed captioning, accessibility features, the latest media codecs, and so forth. And so I think this is pretty cool. This is an MFC C++ app able to now use the latest UI platform features because of XAML islands. So that's really cool.
That's awesome.
Here you go.
Awesome. So we talked about the UI layer and some of the interop there. Let's now talk about the APIs. So the API story for Windows has been pretty much split into two halves. One on the Win32 side, the familiar, very extensive set of flat APIs aimed at desktop developers that we've had for a long time now. And then obviously on the .NET side for managed developers, the .NET desktop framework. And then when we built Windows 10, we came up with a new kind of API, a family of APIs known as WinRT. And WinRT APIs allow us to write functionality in Windows natively once, and then project that functionality so that you can call it whether you're C# or native code or even other languages. So it was a pretty cool innovation, but it was limited to store apps. On the .NET side, we also had some innovation there. We built .NET Native, and this had the ability to compile ahead of time. So at the time we built this, this was really the first time that .NET was getting this great ahead-of-time compilation. Now, if you fast forward to today, one of the big things that we've done is to make WinRT applicable not only in the UWP store domain, but also in Win32 desktop apps. And you sort of saw a version of that with the visual there, but that goes also for the broader set of WinRT APIs that the platform exposes. And on the .NET side, I guess on the desktop, .NET Core has emerged, and this has been very popular. Developers have loved it. And I think recently we've seen .NET Core 3, which has had a renewed focus on desktop developers and a lot of interest in updating some of those desktop experiences. So where do we see this going? Well, in the future, where we see this going is really our innovation in the Windows platform in those APIs will remain in WinRT, because we want to write those APIs and have them be as broadly applicable and easy to consume from anywhere as possible. And then on the .NET side, we really see ourselves standardizing around .NET Core, and so that we can have a single .NET runtime with the great innovations, the great new features in C#8 and beyond coming together there. So that gives a quick glimpse of the API layer. What I want to do now is switch over and show you another demo of how we can call WinRT APIs from Win32. And this time, I'm going to show Chromium. So Chromium is a very significant code base. I'm sure many of us are using this in our daily lives, either through the Chrome browser. Maybe some of you have tried out the new modern Edge browser that's also based on the Chromium rendering engine. Some of you, some fans there maybe. I'm certainly a fan myself. Now, interestingly, in Chromium, the Chromium code base is already leveraging some of the power of WinRT. So for things like geolocation, for things like MIDI, and very recently, our Edge team has actually contributed some upstream pull requests to the Chromium code base to add support for WinRT sensor APIs. And this is cool because we've been innovating in this space, adding support for new sensors. And up until the point where we submitted this pull request, Chromium was actually using our legacy Windows 7 sensor API technology. So fewer sensors supported, lower performance, those kind of things. So to show you a quick demo, if I come over here, sensor info, I'm running Chrome Canary here, so this is actually a pretty recent Canary build. I'm going to come in and just say, let's have a look at the accelerometer, add that, and just enable it here. And if I then tilt my screen and actually trigger the accelerometer to move, you can see those values updating, and that's all being now powered by WinRT. So
that is awesome. So Chromium using the Universal Windows Platform.
Who'd have thought it?
Who'd have thought it? And then finally, the last layer we wanted to dig into was the app model layer. And so when Windows 10 first came out, if you were doing desktop app development, you had what I'll call the Win32 app model. Really, it's just kind of the WinMain function. You just run code. And installation technologies like MSI and ClickOnce. And UWP brought with it the UWP app model, which is a more structured app model that has a notion of app activation and suspend and resume, app contracts, and various things like that. And a new AppX packaging and installation technology, and a store. Since then, we've evolved AppX technology into MSIX, which brings a lot of those benefits to desktop and UWP apps, and also allows all of them to get into the store. And moving forward, we're looking to continue to evolve the app model space to make it less of a hard left-right decision for you, but something that's more of a kind of choice that you can make as a developer later on, not as an initial big kind of breaking change for you one way or the other. And so just to show the MSIX innovations to date, I've got a really double click here. So this is an MSIX package of Power BI, and I'm just going to kick off the installation there. And so this is a powerful desktop app that they've moved to using MSIX for their packaging and installation. This gives them a more predictable experience for customers, more efficient, and look at how fast this is installing. This is a 500 megabyte package, and it's installing and up and running very quickly. It supports side loading as well as being in the store. And it's just kind of giving them a more modern, better way to deploy their application. And also because of that, you can see, yeah, it's a very rich desktop app. It also is allowing them to get into the store. So that's kind of a very quick demo of MSIX, but there's whole talks that are going to a lot more depth on that. I think you'll see that across each layer of the platform, we're really trying to blend things together better for you and move to a model where you can really invest in the latest platform Windows 10 technologies from UWP across all your apps and benefit from them and seize that Windows 10 opportunity.
So what are the takeaways? Well, 4 key points. First one is there's a great opportunity. There's a lot of devices out there, and there's a lot of opportunity for you to either enlighten your existing apps or build new apps for Windows 10. We're building the Windows 10 platform in a much more agile, interoperable, and open way. We really want to lift out key components and iterate and innovate much more quickly. If you are developers using the Universal Windows Platform WinRT today, you're in great shape. You're using the most modern technology we have, and we will continue to make big investments in that technology. And also, if you're a .NET fan, we will continue to bring the innovations from .NET to that same environment. And if you're a desktop developer building Win32 style apps using maybe C++ or .NET, once again, you're in great shape. We continue to support and maintain those technologies and also bring the power of the universal platform to those same apps. So Paul, what are we going to do next?
I want to talk about WinUI.
Great.
Yes. So that's kind of a big picture of stuff. Now we want to dive a bit more into WinUI and the future of native UX development specifically. So what is WinUI? We talked about there's WinUI 2 and WinUI 3. WinUI 2 is a library of controls and styles that you'd use on top of the inbox XAML platform. WinUI 3 gives you the full stack of the platform. And WinUI 2 has been shipping for more than a year now and kind of has multiple versions out there. And WinUI 3, we just launched the alpha preview of this week. And so to visualize that difference for you, WinUI 2 is just some controls and styles. WinUI 3 is starting with that and growing to include the full UI layer. In both cases, you're getting the native Windows platform, the same bits that are used by hundreds of millions of customers a month with billions of hours of usage behind them. So a feature like a menu bar or any other platform feature that's in the platform, you're getting the same implementation in WinUI, the same API shape with all the same methods and events and properties and so forth. What's changing from a developer perspective is the namespace, because it's that way you can be explicit about which one you're referencing, if you're referencing the inbox one or the out-of-box one. In both cases, you're getting something that's independent from the OS, which means that your code can work across in-market versions of the operating system. And so today, when Microsoft adds some feature to the platform in the operating system, let's say we add it to 1909, the latest Windows 10 release, your app can't really fully exploit that unless your customers have deployed that OS version. With WinUI, because it goes across a range of OS versions, you can then use that feature even if your customers are any one of those Windows 10 versions, okay? So it's independent from the operating system. You guys got your photos? All right. It's delivered side by side from a versioning perspective, and so that means you're in control as the developer of when you move to the new version. You're not kind of beholden to someone else to be deciding that for you. It gives you more flexibility, and it's developed in the open. Not just the code, the issue tracking, specs, feature suggestions, bugs, and we invite you to all actively engage directly with us and our development team in the open on this whole technology stack. So that's kind of the big picture about the difference between WinUI 2 and 3. What's new in WinUI 2 specifically? Well, we've had 3 releases since the initial one last year at Ignite. And that just shows the agility that we're getting with this new way of delivering the platform to you, with dozens of new and improved features and customer-driven feature requests in there. That means we're giving you entirely new controls. For example, there's a tab view control in WinUI 2.2. This just released a few months ago, and it's already used in the Windows terminal. So if you're using the Windows terminal, that's using WinUI 2.2 and the tab control from WinUI 2.2. So we're able to get really rapidly, it's a great control. You can see it has reordering and closing and opening and smart resizing and all that kind of stuff. We're also improving popular existing controls in WinUI 2. So the navigation view is a very popular control for people doing UWP development today or XAML development. And we're continuing to refine it based on customer feedback, based on new findings from usability research, and based on our general intent to make UI more dense and productive for people. And so some of the refinements you'll see here are part of an ongoing effort we've been doing to eliminate wasted space and make UIs be even denser and more productive for people. And WinUI also gives you the latest Fluent Design visuals. We update the default theme, but we also do it in a way that allows you to create your own Fluent themes. Because Fluent's not a skin, Fluent's a design system. And while we have default visuals that kind of change as the fashion changes, we're also empowering you to make the right choices for your brand. And so you'll see there's rounded corners in the latest Fluent designs, and then WinUI gives you that, and thinner borders. But what's really cool is that you can actually customize all that and create your own themes that are Fluent. So who here's used the Fluent XAML theme editor before? A couple of you? So this is a tool that we have. It's on GitHub and in the store that basically lets you see the controls of the platform and very easily just flip some colors around to create a custom theme to change them. So here's a lavender theme or a forest theme or a nighttime theme. And all the behaviors remain the same of the controls. It's the same rich interactions and so forth, but it's just customizing them. And so in the past, we've had color support with this theming technology, and now we have border, corner radius, and border thickness support as well. So if your designers, you don't have to be a developer to create these themes. If your designers want to come and say, oh, I want things to be super rounded, except I want the top left corner to have no rounding, and I want them to be thicker, and you can apply, and you'll see instantly all the controls have that new styling applied to them, that theme, and then you can just hit export. It copies some resource values, you copy and paste into your app, and you're done. So that's the Fluent XAML theme editor.
And let's show you another example. So we're going to jump over now to the Microsoft News app. And the News app displays pretty large collections of content. And so actually we had a great co-engineering partnership with that team. They were using the XAML list view, and they actually wanted something that was higher performance. And so we collectively together built a new form of item collection that supports a flexible layout system. So if your item templates need to be customized in a more extensive way, we support that. We support custom views and really high performance data and UI virtualization. And so as we come into the News app, we'll just see really, really nice and clean performance, really great scrolling. Now, if we switch back to the slides, press the wrong button. Let's actually switch back to the slides. There we go. So one of the great aspects of this was the agility that it gave to the news team. So literally within the space of a few weeks, we were able to take this control and deploy it in production with confidence. And so in the past, this would have been a process of the news team waiting for the OS feature to ship and then waiting for that version of Windows to propagate so that they can take a bet. Suddenly now, they have much, much increased agility. So this was a great win and a great collaboration, I think. So we're going to move on now and talk about the visual layer. So I kind of showed a little bit before some examples of the visual layer. But to put the visual layer in context of the broader UI platform, the visual layer really is the rendering platform that Windows XAML is built on top of. And so this means all of the images, all of the bitmaps, all of the rendering, animations, and effects are really being powered by that visual layer. It's hardware accelerated on top of DirectX. Now, we've been innovating and adding features to that layer for a number of years. And some of the most recent things that we added came in the 1903 release, where here we introduced the 3D control. So we've actually added the ability to support 3D in the visual layer. We've added some new APIs, Scene Visual, Scene Node, Scene Component. And these allow you to load really rich 3D models with textures, animations, and complex meshes. And we also added support for common file formats. So GLTF is a very common format used for the interchange of 3D models. And we have a 3D loader control that we're open sourcing, as well as a 3D viewer control. So if you want to program this at the XAML level and just drop the control directly into your app and not worry about scene visuals and nodes, we'll give you that as well. So the second thing that we added was the radial gradient support. And again, those of you that have been doing any XAML development for a while may be familiar with radial gradients from the WPF days. This was a feature that was pretty widely used. But we didn't have this feature in the Windows XAML, in the modern version of the XAML platform. And the reason for that was our rendering layer actually didn't support radial gradients. So one of the motivations for adding this support was to sort of respond to those customer requests and people that are looking for that great support. We've added it. It's hardware accelerated again. It's implemented in a very performant way in the system compositor. And then the final thing I'll show you, this actually hasn't shipped yet. So we've shipped a preview to the insiders. This is a particle system API in Windows. And so we have an emitter visual, and we have a whole physics system that allows different kind of particle effects. You can build things like smoke and fire. And these are pretty popular in some of the other UI frameworks out there. We've had quite a few requests for it. And again, we've added it in the visual layer in the base of the platform in a very efficient way. And so these are just some of the capabilities that we've added. Paul, how do you think this stuff's going to manifest itself in WinUI 3?
That's a great question, James.
Loaded question.
Loaded question. What's coming in WinUI 3 is all that goodness that we showed you about what WinUI 2 is giving you, the goodness that the visual layer is giving you, and all the features really in the UI layer kind of available to you in this more agile way, independent of the OS, and working for UWP and desktop apps. And we launched the first alpha preview of WinUI 3 earlier this week. We've enjoyed seeing all the tweets and responses to that. And we think the best way to show it to you is to demo it. And so I think we're going to do some demos of the WinUI 3 alpha to help you see what's available there already in that.
Let's do some demos. So we're going to show you 3 different demos. I'm going to start off with Hello World, as you would expect. So I have a Visual Studio open. And if I go to my installed extensions, I'll see that I actually have this WinUI 3 project templates extension. This is a Visual Studio extension, a V6 as we like to call them, that you will get if you sign up for the alpha preview and go download the V6 support. So if we come in now and do a new project and search for WinUI, we actually see some of our new templates. Now, this doesn't represent the complete list. We will have more. One of the notable omissions is we don't have desktop support in the initial alpha. That's coming a little bit later. But we're going to start off and just make a C# blank app here, as is our want. And we'll go ahead and create this. And I'll do the thing that we all typically do, which is we'll create a button in XAML, and we'll say Hello World. So let's go to our main page and come and have a little look at our XAML code here. And we'll start typing. So button, we'll give it a click handler, some text. And we'll just jump into the code behind. So what I want to do in the code behind is I want to make a content dialog. Someone doesn't like my typing. And we will set the content of that content dialog to be our string. And we will display it. So we'll need to just call show async. And of course, we need to await it. And we need to make that an asynchronous call. So that should compile, right? That's pretty easy code. What will actually happen here is this will actually fail to compile. And the reason it will fail to compile is something subtle that Paul mentioned earlier. Even though the object model is identical, we've actually moved the API into a new namespace. And so what you'll see in my button click handler is, because we haven't yet updated the tooling fully to support the new namespace, what I'll see here is that I'm actually in a Windows UI XAML namespace. And instead, I actually need to be in the Microsoft UI XAML namespace. So if I do that, we should make the compiler happy, and we should be able to run this project. And here we go. Let's run it, and we will hopefully see an app running, and we'll say hello. Now, not the most thrilling app. And
I'm excited.
You may be questioning me and going, well, how the heck do I know this is actually something new? This is WinUI 3. So I'm going to come into Process Explorer, and we'll just search for app 26. I have been pressing this a few times.
There it is.
Is it there? There it is. It's selected. So if we come down now and have a little look at what DLLs and assemblies are loaded, you'll actually see I have the Microsoft UI XAML DLL loaded. And the interesting thing about this is, you can tell it used to be Windows UI XAML, now it's Microsoft UI XAML. But also, if you look at the path, you'll see that this is actually deployed as part of my application. So we actually have different deployment schemes. You can pick which one you prefer. In this case, I've chosen to package it all in with my app. So I get the side-by-side versioning. I get the deterministic knowledge of the specific version. So this is how we would prove that it's WinUI 3.
And that's all the alpha preview lets you do, but the final one will let you use framework packages, so there's just one copy of the DLL on disk and being deployed. You don't have to have it bundled in your app.
So that's not the world's most exciting demo. Paul, have you got something a little bit better for us here?
I think so. So a common way people learn about and see all the features we have in the platform is with the XAML control gallery. Is anyone here familiar with the XAML control gallery sample? Some of you have seen that, used it? So here what we've done is, in addition to shipping the alpha of WinUI 3, we've shipped a version of the control gallery that's been redirected to WinUI 3. So you can go experience and feel exactly what's working and not working and try it out. And so, so here I am building it, launching it as a pretty new header. And so one thing I want to show you first is just to prove what's going on here. I'm going to winver, and you're going to see I'm running an 1803. Okay, this is the April 2018 version of Windows 10. So this is 4 versions ago of Windows 10. And yet I'm running here with the control gallery sample. And you can see if I scroll down here, kind of all the controls and things that are available. Ones that are grayed out are ones that are not yet available in the preview. So there's no ink canvas yet. There's no media player element yet. If you scroll down, you'll see there's no reveal and there's no web view, for example. But all these other things are there. So there's a lot available already in the preview, and you can go play with features. For example, I mentioned that tab control, and so I can go find the tab control. Here it is, tab view, and I can go use that, and I can go close tabs and open tabs and so forth. So that's there, but of course that's there, because WinUI 2 includes that already. So what's new? So there's also new features people have asked us for that we've thus far not been able to deliver in market for them. Things like input validation has been a common request, and input validation will be in WinUI 3, and it's in the WinUI 3 alpha already. So you can have things like I'm typing my card name, and I start typing, oops, it's not my address, I want to click here. And it'll tell me, oh, not enough characters, and then when I type one more character, it fixes that. Or I can have checking for lack of numbers. I typed an alpha character, not a numeric character, and it gave me an error. So new features can be available to you now, also right in market. So yeah.
What about some animations? Let's see what else we have in here. So if I come back and look at my list of controls, we have a control called Animated Visual Player. And again, this was added pretty recently. And although a lot of developers gave us feedback, yeah, we really love this, they were, again, unable to really take advantage of it because the version of Windows that contained support for it was not sufficiently well distributed. And so here again, we're running on the 1803 release is our animation system. This is something that we call Lottie. It's an ability to take animations that your designers make in After Effects and easily create animated vector files that play with hardware acceleration. And here it is running in RS3.
This is really popular for animated icons and a lot of different uses.
Exactly. So what other?
So that's cool, James. But what about those brand new features you just showed us in the visual layer?
Yeah.
Even the ones that aren't even shipping in the operating system yet.
Let's see if
Are
those
those
work.
available?
Let's see if those work. So here I have a different project. This is a C++ project. I have a Win32 target and a UWP target. So if we launch the Win32 target, this is using now the visual layer that I showed you before, but a version of the visual layer that is lifted out of the OS and shipped out of band. So in the same way that WinUI is available as a NuGet package, part of that NuGet package is actually the visual layer. So if I come in here and actually click around, I can create those animated radial gradients that I mentioned, or I can even come in and create some particles. So this is great. This is running on my up-level machine. Let's now retarget and actually send that to the virtual machine and see if it will work there. And I just have to try and see where to set the startup project. There it is. I'm being blind. OK, let's do it. Switch back to the VM. And this has a black background. I'm actually, in this case, using the UWP version. And I guess one of the nice side effects here is exactly the same code is easily able to switch and target between desktop Win32 and UWP. And as you might hopefully expect, here we have our nice animated radial gradients, and here we have our particles.
Awesome. So even those brand new features, some of which haven't even shipped in the operating system, are now available through the alpha and will be in WinUI 3.
Right. Awesome. So those are our demos.
OK. So just to kind of paint a picture of the roadmap of getting from the alpha to the release of WinUI 3, what we have now has a partial feature set. I pointed out some of the gaps, and you can go to the website to see the full list of all the known kind of gaps. But we'll have the complete feature set before we ship it. In terms of quality level, we think it's ready for you to explore, understand, try porting your apps to it and see what you find. We do not recommend you try to ship or put in any commercial production, anything with the alpha, but go try it out. And by the time we release, it'll be ready for you to ship publicly. It'll be stable. It'll be supported with a framework package so we can do updates and so forth. It'll work all the way to 1703 eventually. Now it's down to 1803. We'll support UWP and desktop app models directly. Right now, the alpha is on UWP only. And the language support will extend to .NET Core, the latest kind of .NET Core at that time, as well as, and one of the next things we're doing is in the open source space. Right now, all the WinUI 2 code is open sourced, and issue tracking for all of WinUI 2 and 3 is open sourced. And one of the next projects we're going to be doing is taking WinUI 3 code that's not already open source and moving that into the open. So that's something you should expect in the first half of next year. So that's kind of the path ahead there, and you can learn much more on our site, and I'll show you a link to that at the end. And then finally, something I wanted to address is we sometimes get a question. People say, wow, this is so cool. We're so excited about the Windows 10 developer opportunity, about creating these great apps that exploit that and work delightfully on all these devices. But we have some apprehension, Paul and James. We worry that we might still need in our organization to support Windows 7 in some cases. We need to sometimes get to think about cross-platform, make sure our stuff has some way to work cross-platform. And how does WinUI fit into that, and how does that connect here to the story? And so I'd like to talk about today, the state of the world today, how that stuff connects up. There's a number of popular cross-platform frameworks people are using today when they talk about native UIs, not the web UI space, but the native UI. One of them is Xamarin Forms. And that's excellent. There's, I think, a couple other talks on Xamarin Forms at the event today, this week. And if you're using Xamarin or Xamarin Forms to reach Windows, you're actually building on the UI stack that I've been talking to you about in WinUI. In fact, some of the higher level controls in the Xamarin Forms shell now on Windows are actually just mapping over the WinUI controls. And in general, you're able to access this full richness of those Windows and Windows UI platform when you're doing that and reaching Windows with it. So if you're using Xamarin Forms, you're actually going to be using WinUI technologies to reach Windows. The same is true with React Native. That's another kind of parallel technology to Xamarin Forms for JavaScript developers. It's very popular. And we announced at Build the React Native for Windows project. And so people are already starting to use that to reach Windows. And again, that layers over this UI technology we've been showing you and talking to you about in WinUI and plays with that. And you'll be able to access that. Another big announcement has been the Edge browser moving to the Chromium engine. And a lot of people for cross-platform development do hybrid apps where they have some native UI and then some web UI and web views they host in there. And so we're going to be having that Chromium Edge web view engine available to use in WinUI and interoperate with WinUI UI. And so that's something else that kind of, and you can use the accelerometers and the other features that kind of we're adding into that. And so these are great. And then one final one I wanted to talk about is Uno, which the great folks at Inventive, I think, have a slogan now, WinUI everywhere. And so they've been doing some really awesome work to bring WinUI into the browser with WebAssembly and other places. And we think this is a really cool solution for people who want to make sure they have a way to get to Win 7 or maybe some other places with their WinUI code that they're worried about, oh, can I get there? And we thought about different ways to show this, but I think the coolest and best way is to literally demo. And this is going to be, maybe some of you see this all the time, but I haven't looked at a Windows 7 screen in a while. This is Windows 7. And we've shown you the sample gallery running on Windows 10. We've shown you running in different versions with WinUI Alpha. And here the folks at Inventive have actually used Uno to bring it into the browser. So here I have, So here you have the sample gallery. They've ported it using Uno with WebAssembly into the browser. So you can see the list of all the controls and things they've gotten working there. And you can kind of click on them. So I'm going to click on slider is one that I think is kind of fun to see. And that's that slider control from WinUI working there in the browser. So I think it's a really cool solution that folks are now making available. All right.
All right, so takeaways. WinUI 3 is the future of UX development on Windows. And it's available both for desktop and UWP developers. And we're also excited to work on different cross-platform solutions that will leverage WinUI 3. Paul, how can folks get started? All right.
So getting started today, take advantage of the Windows 10 platform stuff we've talked about that's already shipping. WinUI 2 is the latest version. XAML Islands and Visual Layer, the WinRT APIs, MSIX, we showed you all that kind of shipping working today. Check out the WinUI 3 Alpha preview. That's the URL where you can go get it and sign up for it. Engage with us on GitHub. Follow us on Twitter. Come talk to us. We'll be at the hub afterwards. Oh, and here's one fun thing I want to share about the Alpha. We published the Alpha on Monday, and on Tuesday, someone had already ported one of their apps to it, and he said it took him 30 minutes. So that's pretty cool for an Alpha preview. So, thanks.
And do please fill in the evaluations. We love evaluations. That would be awesome. Thank you so much.